again. Are you live on YouTube or not yet?
Yes.
Did you press go live on YouTube?
Now we are.
Nice. All right, cool. I'll leave you to it. Cheers.
So, thank you. Thank you for the introduction. So yeah, I'm Francesco. I'm the co-founder at Apibara. And today we are going to see how to analyze on-chain data using Apibara and ChatGPT. So what is Apibara first, right? And I think it's the fastest way to build production-grade indexers. And we do that by connecting Starknet data with existing Web2 services that you already use and love. And we make it very easy to do that. But first, it's the faster way to build the indexer, but what is indexing exactly? And it is that in a blockchain, we have the blockchain state, which is, for example, the balance you have or which NFTs you have. And we want to update them by sending transactions to the network. That's what we do when we click approve on Bravos or Argentex. And basically the sequencer, what it does, it takes the previous state of the blockchain at the previous block, then it takes the transactions that the user submitted, and use this information to produce the new state of the blockchain. And basically we get a Starknet block, which is nothing more than just the Starknet state, so the state at the new block. So with all the changes that happen because of the transactions. It contains the transactions on the network and the receipts of these transactions. So what happened when executing the transactions. And usually we have that events, which is probably like what 90% of you are interested in. And then, but we also have messages between L2 and L1 and between L1 and L2. And the idea is that indexing is just updating off-chain state based on these changes that are happening on-chain. And obviously, we don't want to do that only for one block. We would want to do that for every block on the chain. And as the blockchain produces more blocks, we want to keep repeating that. And that's indexing. So what is Apibara? The idea behind Apibara is that we make it very easy to build indexer. And we basically build first what we call direct node access, which is a very low-level protocol that is very efficient and is a way to stream on-chain data into your application. And today we are not going to use that directly, but it can be used using, for example, one of the SDKs we have for Python or TypeScript. And that's how most of our users are using Apibara now. I think the future is to use integrations, which simplify a lot of the tasks that we see developers do over and over again, by basically having these programs that do something simple, like, for example, taking on-chain data and sending it to a database or to HTTP API. And basically, that way it's very easy to integrate on-chain data with your Web2 applications. And so our slogan is stream, transform, integrate. And now, because that's the 3 steps that it takes to actually build the indexer with Apibara. So with streaming, we say, okay, we have a full Starknet block, right? There's a lot of data, but we are not interested in that. We are only interested in a subset of this data. For example, today we are going to analyze 10K swaps. And so we are going to only want that type of data. So we filter the data. So we go from a lot of data, like several megabytes of data, to only a few events and changes at every block. And the next step is that we want to transform this data in a way that in a shape that makes sense for our application. And as we are going to see, we are going to do that using JavaScript and this runtime called Dino. And the idea is that we take the block with the state changes, the events, the transactions, the block headers, and everything. We reshape them together into basically some data that makes sense for our application. For example, new rows that we want to insert into a database, or maybe a payload that we send to our webhook. So we can be like a Telegram bot or a Discord bot, right, very easily. And the idea is that the last step is integrate, where we take this data that has been produced by the transformation and we add it to another application. For example, in this case, we just send it to Supabase. And so each item in our list will be inserted as a row in the table. Or it's very easy to switch, and we can send it to a serverless function. So we can call like a AWS Lambda function that will execute some code and then maybe call another API, right? The reality is that it's up to you. I'm sure each one of you has different developer tools that they like. And the cool thing about Apibara is that you can keep using them. You don't have to learn something new. You can use what you like. And so I think it's more fun to build applications that way. And so, again, stream, transform, integrate. The idea is that we keep repeating the process hundreds or thousands of times per second. So every time there's new data being produced in the blockchain, we keep repeating these steps. So our data in our database is always up to date. And that's really all it takes to build an indexer. And so today the goal is that we take a 10K swap for the ETH USDC pool. we filter and we transform it with Apibara. We produce some new data that then we handle to Supabase. The data will be inserted in a table. And it is that at the end, we use this library called LangChain together with OpenAI to basically ask questions about this data in a very natural way, like you would ask to a person, and then that back the result without having to write any SQL code, which maybe you haven't used in a while. And it's very easy to forget how to write SQL, and so that way it's much easier. Yeah, so that's all. And now we can start coding. So the idea is that here I have a new project. You can see just it's an empty project, has nothing of interest inside. And now we want to use Supabase. So we use the Supabase command line tool to initialize a project. We do yes. And now obviously we have an empty Supabase project. And so, yeah.
Could you please share what are some of the prerequisites or installations that folks would need to have in order to get started?
That's 2 points. So for this workshop, we need to have a Supabase installed and a version, basically the command line tool from Supabase and the command lines, etc. Like programs that we have in the Apibara repository. So DNA. So basically this repository, we have a series of obviously what we call scenes or integrations, and they can be compiled and installed. And we are going to have binary releases later today or tomorrow.
Okay, great.
Yeah, so the idea is that now we have a Supabase project, and we can run Supabase locally, which is very cool. So we can do Supabase start, and now instead of using, Supabase is also a hosted service, so we can go on supabase.com and run it over there, or we can run it locally in our machine, so we don't, everything is in our control. And now they are, launching the containers and basically launching the database and everything. So I have a complete development environment running locally on my machine. And now I get all the connections. I get a connection string for the database, which we will use later to tell Apibara where to write data. And I have the Supabase Studio, which is basically like a complete interface for my database. Now here I just see I have a project. There's no tables because we are going to create that soon. So let's do that. So how do we do that in Supabase? We create a migration, which is basically a way to tell the database what tables we want. So we go back to the command line, we say Supabase migrate new, we call it add tables. Supabase migration new. Okay. So I go back to VS Code, my migration tables. I have a SQL file that Supabase will execute to create my table. And it is that I have some code. Okay, now we can create the table and I have the SQL code to that. And so we're only interested in tracking the swaps. So we create that table called swaps. And we want, for our production deployment, we want to track which exchange that swap is for. So it could be 10K swap, it could be ZS swap. The name of the first token, the name of the second token, and the address of the pool. And then, because we are going to build a dashboard or something like that, we want to track basically at what block number the swap happened, and the block time, so at what timestamps, and the transaction hash of the swap. And then we want to keep basically track the swap data. So we will have the amount of token 0 and token 1 that the user transferred to the pool, and the amount of token 0, token 1 that the user transferred out of the pool. The sender address is basically the person that performed the swap, and the to address is the person that we received the amount of money after the swap. Usually it's the same person, but not always. And then we want to have something basically that's, all these numbers will be tricky. And we want to basically compute the price of token 0 in terms of token 1 and the price of token 1 in terms of token 0. So we want to say, what's the price of ETH in USDC or the price of USDC in ETH? And we can compute that value for each swap. And finally, the last value is something that's needed by the Apibara integration, which is basically what we call a cursor, which is nothing more than the block number. And we use that to invalidate data when there's a chain reorganization. But that's a bit more advanced topic, so we can sort of ignore that for now and just say you need to have this cursor column in your table. So now we do Supabase migration. Okay, and now Superbase apply my mid ratio, and now we have a table which is empty in our database.
So,
And so,
Francesco,
yeah,
you mentioned some of the parameters that you wrote in the .sql file, right?
yeah.
Uh, is there a place where people can go and look at the parameters? Like, are the name of the parameters, do they
Oh,
indicate like somewhere, like, is it there on scan or like parameters that are sent to the contract, or where do we get these names?
that's actually a good point. So the only parameters that's required is this underscore cursor. That's
Mm.
the other parameters we can decide the name. Again, the idea of Apibara is that you are in control of your data, right? We don't want to tell you how to shape your data because you are the expert on your own application, right? As we see later in the transform step, we are going to take the raw blockchain data and reshape it so it has exactly this shape. But if your application is doing something else, it's not swaps, it's maybe you're looking like a ZK land or you're looking at some chain, you can create tables that have exactly the shape that is needed for your application. And I think that's very powerful.
Okay, interesting. Thank you.
Yeah. So okay. So now we basically did all the setup that's required, and now we can start streaming on-chain data. And so we could send data directly to the database. By my opinion, right, I always need some time to debug what I'm doing, and so for that we use the webhook integration. And so on my computer, I started like a small HTTP server, which is nothing more than a Docker image, that we simply print out the payload I'm sending to the server. Okay? So that way we can debug what we are doing in the filter and transform phase. So let me go back here. And now I want to run the webhook integration. So the webhook integration takes some arguments. The first argument is the stream URL, which is the Apibara DNA stream. In this case, we are using a mainnet stream. So we have mainnet data. We want to stream Starknet data. Okay, and on Apibara, we need to authenticate using the token that we generate from the interface. So if you go, oops, now you have my API key. I will have to delete it later. So if you go on Apibara, you will get this API key. You can create your indexer, create your API key. You need to copy that so we can track basically how much data you're using to avoid that someone is, streams too much data and sort of like ruins the system for everyone. So that way, if your indexer is working or not. And we basically set up that. We tell the webhook to authorize that. And then we can tell which block we want to start streaming data. We can do, so for example, I'm looking at the pool on StartScan, and I see it's been deployed at this transaction. And this transaction is a block 5,000. So I want to start streaming data from that block. Okay, so it's block 5,000. So I will change here so that we don't miss any data. Okay, and then I say, okay, it's a webhook. I want to post the data from this, from Apibara, from on-chain to my webhook running locally on my computer. And the next step is that we need to set up a filter. So we create a new folder here where we will put all Apibara stuff, and we create Apibara. We create a filter, which is a JSON file that basically tells Apibara what type of data we are interested. If you remember from our presentation, we are basically doing this step here. We go from having all on-chain data. We want to filter this data down to have only the 10K swaps. And we use that with the JSON filter where we say header. So we say weak. True, we means that we want to receive a basically block header only if any other type of data is generated. And then we want events. So we go to the 10K swap contract. We say we want all swap events generated by 10K swap. And so we go back to StartScan, and here we say, okay, the contract address is this one. We copy it, paste it there. And now we go for swap events here. We open one, right? And the reality is that Starknet it doesn't understand about swap events, but it has the hash of the event name. And on Starknet it's pretty nice because you can just copy that value. And that's the event key. So every event that has this key is a swap event from the 10K swap pool. Okay, so now we go back to the command line. Here we change the argument to filter to Apibara/filter. Okay, and then I made a mistake in my, okay, so it's not key, it's keys. That was a mistake on my part. Okay, now we getting a lot of data and it's streaming very fast, so it's pretty annoying to look at that. And now it's printing a lot, okay? But we see the data we received. That's the raw data that Apibara is sending to our integration. And we see for each event, we have the transaction that generated the event. So we have which contract sent the transaction, which method we called, and basically the code data, because on Starknet you can have multiple transaction, multiple calls in one transaction, and here we can have all of them. We have the transaction receipt, so the data that the sequencer generated after accepting the transaction. So we can see, for example, how much fees the user of that transaction paid. We can get the transaction hash, so we can even save that, and then so it's easier to link to a Starknet page or a Voyager page. And then we see all events that were together in that transaction. And then we get the finally the event. And we see both like the address that generated the event, which is obviously the 10K swap pool. And we also see the raw data of the event, which if we go back to Starknet, we can see that. And we will see that this data here is the same as this data here. Obviously, it's not the same event, so the data is slightly different, but the size is the same. Okay, and now we have everything. But now, obviously, like if I don't want to insert this data in a database, it's like not in the shape I want. It's very tricky to work with. I want to reshape this data to actually be useful and like nice to use. And for that, in Apibara, we have this concept of transformation, which we have here. So now we are going to do this step where we take this data that we have now, right? Which has this odd shape, but it's not too much data, but it's still odd shape. And we want to run a piece of JavaScript code over this data to actually produce some data that is a nice shape. And so how do we do that? We create a simple JavaScript file. So we go back to Apibara, we create transform dot. So the file name could be anything actually. And now let me find, okay. So what we want to do is that is a Dino runtime. So the cool thing is that we can import any JavaScript library we want. So for example, I can import these two libraries, use Starknet.js and VM, which is like a library for EVM change. And we are going to use VM just to format basically big integer. And also we know that we are working with ETH and USDC. And as you maybe know, if you go back here, we see that the amount of token 0 is like this huge number. But the reality is that the user didn't deposit like 200 billion ETH, right? They deposited a much lower amount. But because on Starknet, we cannot represent fractional numbers. So we cannot represent like 2.7. So we need to add many zeros after the fractional part to transform it into an integer. And that is that way we can represent very, very small amounts of units of, say, ETH, but we represent that as an integer, not as a floating point number. Okay, so that's the number of decimals. So ETH has 18 decimals, USDC has 6. Okay, so now we can go down to actually be like the transformation phase. So we do like, so we basically have this transform function, which is the default export of the basically JavaScript file, and we receive a batch of data. So because Apibara tries to be very efficient, it will not send you data block by block. It will send you maybe 10 blocks at a time for historical data. So that way you can insert like 10 blocks of data at a time into your database, which is much more efficient than going block by block. So your indexer will run faster, which means that you can resync everything much, much faster. Okay, so I do for each plot, I want to extract the events in that block. Okay, so now I create a new function called like under block. Okay, and now we have a block which is similar to this data we have here, where you have many events and a lot of things, right? They are quite full blocks, so it's difficult to see now. What we can do is that we know that this block will have headers and events. So I use classic JavaScript, and then I do, okay, so I want to map each event, it could be null, maybe. I want to go just map. And I want the event and the receipt, not interested in the transaction for this case. I say handle event, header, event. Okay, and now I create the under event function, and finally we can do the reshape of the data, right? And I think what's exciting is that, I'm just writing normal JavaScript. I don't have to learn any new library. I can use exactly what I wanted. Okay, so now the next step and the final step is to decode call data for the event. So this data, we go from all these field elements that don't really tell us anything. We go to this nice representation of things. And we go to even better, where the amounts are not like just a big integer. They're actually floating point numbers that we can understand. Okay. So the way we do it is that we can say, okay, so the sender address, just the event.data is the first element, right? So this one is the, extracting this value, which is the sender. Okay, now for the other amounts is a bit more tricky. Okay, I just pasted some code because it's over the same. We say, okay, we want to convert these two field elements. So if I go back to row, these two field elements into a big integer. Okay, and I do that using the Starknet.js function, because I can use any JavaScript library. So I say, okay, so I take these two field elements and convert them to a big integer. And then I don't want to have a big integer. I want to have like a decimal number. And so to do that, I use the format unit function, right? So when it receives a number that looks like that, it will convert it to basically like a string, which is something like 0.2.67. And then we use the plus before, which is a JavaScript thing, to convert from string to a number. And we do that for all amounts here. And finally, we have the to address, which is this element here. Okay, and now that we have the numbers, and we have the amount of token 0 and token 1 that the user put inside, and the amount of token 0 and token 1 that the user got out, we can convert the price, the swap traded at. And we do that this way, right? So we say, okay, the user put this, basically the total amount of token 1 was the amount that the user put inside and got out. And the total amount of token 0 was like the one that user put inside or took out. And basically that gives us the price the user traded at. Okay, and now we almost finished, because now we can finally return the data we want to insert in the database. Okay, so now we go back to the SQL file, right, where we have all these columns, and you asked basically, where does this name come from? And basically I had a clear in mind what type of data I wanted to put in my database. And I knew that my transform step will return that, right? So you can see that I have the exchange, I have the token names and pair. And then I have this information that comes from the block. So I have the block number, block times, and the transaction hash. And then I have this value that I just computed, right? And now basically this data, and Apibara is going to basically call my JavaScript function. On each block of data is going to stream, and then it's going to send this data to the webhook or to a database with one integration we wrote. So let's run it now. And of course, I forgot to I need to tell Apibara, okay, just use that script to transform data. So I need to say transform equals Apibara / transform.js. And hopefully I didn't make any mistake in my thing. I run it for a bit, and now I go back, and I see that now we go from the data was like in a very messy format to something that's very tidy, right? We have data that anyone can understand. And so, for example, we see this swap here. We had like the user put inside 32 USD and got back 0.02 ETH. And the price of ETH at that time is like $1,294. Okay. Now we basically, we are creating a webhook, but we said we want to analyze this data using ChatGPT, and we know that ChatGPT is quite good at writing SQL. So why not send data to a SQL database? And we can do that very easily by changing the integration we are going to use. We're going to use the scene Postgres, which requires a bit different arguments. So we need to say how to connect to Postgres. So we give it a connection string, which is what Supabase gave us earlier. So it should be Postgres equals Postgres 54322. Okay, and then we have to say table name, which is the name of the table we created earlier, which is swaps. So like our table is the empty. Yeah, swaps. Now we do that, and hopefully, okay, now our integration is writing data to our table. As you can see, it's writing like probably like a few hundred blocks per minute. And it's mostly because the servers, like the Apibara servers, are in the US. I'm in Europe, so it's a bit slower than what it could be. But still pretty fast, right? We just inserted like 43,000 events while just we were chatting, right? And as you can see, the good thing is that now we have this data, and it's like in a table. And now we can analyze with SQL. So we can go SQL editor. I can say, okay, how many rows do we have now? And it tells me, okay, now we have like 100,000 rows. Now it's like 117,000. And this data will be, Apibara will keep updating the table. And when it reaches the top of the chain, it will basically keep inserting data as new blocks are produced. And if there's any chain reorganization, we'll invalidate data. So it's pretty nice. And basically the Apibara integration part is done. Just streaming, we're inserting data, right? But now we said, I don't want to write any SQL, right? Probably set count is the most I can do from in SQL, right? I don't want to write anything. Let's use ChatGPT and OpenAI to do that. Now we can basically create a new script. We create a new folder. We create like AI. And basically this script, we just call the OpenAI API to generate SQL for us. We are not going to use OpenAI actually directly. We are going to use it through this library called LangChain. So let's install the libraries. And to do that, we have this dino.json file. So we could have used like Node.js, just I like Dino. Okay, so here I say, okay, I want to install the LangChain package, which is this machine learning package for TypeScript. I want to give access to Postgres, so I install like some libraries that do like Postgres interactions, and then I want to basically have like sort of like a nice interface. So I use these two node packages to build like a nice command line interface. We could be like a React front end for it, but it's too much work for a demo, and it's not the important part. But it is that you can build anything you want.
Francesco, quick question. Is LangChain similar to OpenAI? Basically, like it takes in a text input and tries to
So
get data.
basically, LangChain is a library that wraps the OpenAI API, and it makes it a bit easier to use. And they have like a lot of integrations. And what we are going to use today is to like agents. And the idea behind agents is that they use the ChatGPT to think about what to do, but they also have external commands to basically get more information, to interact with the outside world. And we are going to see how that works too. Okay.
Okay.
So I'm going to copy and paste my code, and now we have everything ready. Okay, so the idea is that we have our main function. We basically set the data source to our basically super-based database running locally, which has very secure credentials, right? So Postgres, which is the same where we are writing data. And then we basically just copy and paste some code from the Langchain documentation. That's how to connect the database to this agent. Then we say, okay, how to connect to OpenAI. And here I had to basically set the environment to have my OpenAI API key. And then, okay, we basically said the agent should be able to access a database, right? And so we use this SQL toolkit, which is a library that Langchain implements, that basically instructs the agent how to access data about the database. So it can get a list of tables, can get the shape of a table, and can also basically write and execute SQL code that then is run against the live database. And finally, we create the executor, which is basically the agent. Okay, so then we keep repeating a thing where we can ask ChatGPT anything, right? We ask a normal question, and then based on the input we give to the agent will take some actions, and we are going to basically print the output and also see what steps the agent took. And then we print it like in a nice way, so it's a bit more visual. And now we are still writing data, and I need to set up a CLI with my OpenAI API key. So sorry. Yeah. I don't want to leak my OpenAI API key. So, sorry.
Yeah, that's a good move.
Yes, it's on the other stream. Okay, now we have here, and we should have my OpenAI API key. We go to projects. Okay, so now we can call Dino on our program. Okay, so Dino has this concept of permissions. So for security, we not allow the program to access the internet unless I allow it to do. Okay. So say, okay, you can ask what was the volume in, say, March. Okay, so it has access to our table. It's going to call the OpenAI API, which is quite slow. Anyone that uses the API knows that it's slow. And eventually will give me answer. Hopefully soon. Yeah, that's the life when working with OpenAI. Here is writing data. You have like, it's fine. Okay, so I say the volume in March was 0. That doesn't look right. So I want to see what's happening, right? So here I can see what the actions that the agent took. Okay, so the first action it took is basically list the tables that are in my database, and they see the swaps table. They say, okay. And then it says, I want to see the schema of this table so I can write SQL code. And then basically they see the schema. They see which column. So it's very important to give good names to the columns so the agent has actually a bit more understanding of what's happening. Okay. And they say, okay, I can query the swaps for March. But as you probably know, right, OpenAI was, they stopped training based on data from 2021. So it's saying March of 2021, not 2023, right? So we need to specify that we want May of 2023 because that's the, this March. And also, I know that that's not how you filter based on dates in SQL. So I think he made 2 mistakes, right? And part of basically working with ChatGPT and all these agents is to, basically write good prompts, and that's like prompt engineering. So I'm going to ask them the question. I say, what was the volume in March 2023? Use the date trunc function. Okay. Now I tell ChatGPT 2 things. One, I want March 2023, not March 2021, because that's the current year. And the second is that I want them to use the date trunc function to actually to basically filter by the mods, right? And now we get a value that looks closer to what it is, but there's still some issues, right? The reality is that he only summed the amount of token zero, so the amount of ETH that people traded. In reality, what I want to tell ChatGPT, we are not going to do it today because it takes some time to read good prompts, is that we also want to teach ChatGPT how to convert, say, the amount of ETH into USD by using, for example, the token zero price column that we have, so that it can give us a value in USD instead of telling us just a value in ETH. Okay, but I think we showed that in less than like half an hour, we were able to go from zero to set up a project and keep streaming data into the database, catch up with the team. We fully synced all the swaps. So like I think it's like 100, like I don't know, like we basically almost synced like 1 million events while we were just writing the code for the rest, right? And copy and paste it. So it's quite fast, right? Something you can do over and over during your day while you're developing. And now we have a good starting point to basically be the agent that knows about on-chain data. So I think that's all. And it is that, yeah, so, you can go, if you want to basically use Apibara for your application, continue building on what we started today. Maybe you want to turn it into a product, right? You can get a free API key on apibara.com. And so we are also going to launch integrations like live so that you can deploy and we run it for you. So you don't even need to run servers, right? Everything is serverless from the point of view. And again, everything I showed you today is open source. So make sure to go on our GitHub page, put a star, see what issues are open for contributions. And also remember to follow us on Twitter. Also my account where I tweet about this data stuff and general development things.
Amazing. This was like super quick, and I think this has been like one of our fastest community call workshops. And it was also very interesting, Francesco. Thank you so much. I saw that like there were like about 1 million events through which we were able to go through, get data, etc. Which
Yeah.
is, and it was super fast. Like basically we did it all within a couple of minutes, and that's very cool. And if you have any, like, do you have any repositories that you could share? Like, for example, of course, hiding your open AI API key. Do you have any repositories where you can share in terms of like code that people can see? How does the chat GPT, how does the Supabase
Yeah.
integration, etc. work?
Yeah, so I'm going to upload, we are going to have a tutorials repo where we put all the tutorials that we are going to write today and in the next few days. And so if you follow the Apibara organization GitHub, you will see a tutorial repo coming up very soon after this talk, where you can find the code that I showed you today so that you can run it on your machine.
That's amazing. And if folks have questions on, so Apibara right now is from what I understand from your initial presentation, is like open source to use. Like
Yeah.
folks can write their own custom indexers, etc., as you mentioned. So
Yeah.
if they have any questions, where can they reach out to?
So they can, if it's a technical question, they can use our Discord server, or they can
Okay.
ask on GitHub. And also, like if they find bugs with they can open an issue on GitHub. I will fix it. Or if they want to start contributing, so it's a project in Rust. So it's a good way to learn Rust. They can also contribute on GitHub.
Okay, that's amazing. So for those of you who are interested in contributing as an open source contributor, then you can do that using the Apibara GitHub that's
Yeah.
mentioned over here. And yeah, for all
Yeah.
of you who have been looking to find an intersection between analytics, blockchain, and cutting edge tech like Starknet, I would definitely recommend contributing to the Apibara repo. It might be a great learning experience, as well as, of course, working at something very very new at the intersection of something very very cool. So
Yeah. So
amazing.
if there's any integration you want to see, there's like maybe some Web2 project that you really like and you like as a developer too. Like for example, like Supabase, right? But maybe you like Firebase or other projects. Just open an issue on GitHub and we can write an integration for that. So it becomes like this, right? You just run a command and you get your data in the other application, right? Without having to write much code or like just a simple JavaScript script.
Awesome. That's amazing. Thank you so much, Francesco. Thank you for your time. And thank you, everyone who is able to attend the call with us today. If you have any questions, feel free to reach out. Like, you can also put your questions on the YouTube live stream, and we'll make sure to get you the resources, the answers that you need. Thanks, everyone, and have a great week ahead.
Yeah,
See
thank
you.
you.
Yeah.
See you.